Okay, I want to create a test bench in Xilinx 14.5, but this should work for older versions as well. I'm going to have a project. It's going to be a 8-bit register, and I'd like to test it. And before I get going, I'm going to actually open up that created project already. I'm in implementation. I want to add a new source, or add the source, and it's register n-bit. So it's got inputs of load, clock, clear, and D. Those are my inputs. And my output of Q. Here's the architecture for it. And now that I've got it in here, I'll just synthesize it. And it works. Now if I go to simulate it, and I simply click on the iSim simulator, it comes up here with a bunch of values that are not initialized, so they're in orange. And I have the option in this window of restart everything. So I'm starting at 0 again. And then I can put a clock in. Of course, a clock. And it's 0 to 1 with a period of 100 and then simulated. For 1 microsecond, I can see my 100 nanosecond clock signal. But all I can do is drive a clock or drive to a constant. I can't, for a certain amount of time, force it to one constant and then to another. For that, I need to write a test bench. Additionally, I can only drive 1 bit at a time. So I'd have to drive each one of these bus lines in D7. I'd have to drive them individually with a clock. So I don't want to do that. So what I need to do is write a test bench for this code. So what I'm going to do is, while I'm in simulation, I'm going to add a new source. And it's going to be a VHDL test bench. And I'll call it test register. Creates a new file called test register. It's a test bench. It looks a lot like regular VHDL code. In fact, you have to follow the same syntax rules that you did when you created your main file. It has all the loads, all the signals that you created. It initializes them all to 0 at the outset, so that when the simulation begins, they're all 0. It assumes that you want to toggle the clock, and it does that at a period that's defined here. So you can define the clock period here. At this point, it's 10. I'll make it 100 nanoseconds. And then what I need to do is input my values here. And what I will do is get rid of this weight. I use their initial weight of 100 nanoseconds, but I'll change it so that I'm slightly off of the clock synchronization. The reason for that is I want my clock, this is my clock signal, I want my signals to be slightly displaced from the edge of the rising edge of the clock. So I start at 190 nanoseconds. Now I can start thinking what signals do I want in order to see if my circuit works. So for this particular register, I'll let them all, for the first period, I'll just leave them at 0. And this I left it at 190. And then I want to bring signal B up to a value of AB, leaving the load and clear at 0. And I'll bring the load up to 1 for this period, and then I'll bring them all low again, and then I'll clear at the 4th period, and then clear them all again at the end. So that's what I want to do. So after 190 nanoseconds, B Okay, I think that covers all the inputs that I wanted. I'm going to clear them here, and then clear set to 1, and then clear set to 0. Let's see if I got any. So I'm going to highlight this, and test register test bench, and then I'll check my syntax. And then I'll go ahead and run it out on the simulator. It's simulated for 1 microsecond. And right now I'm way zoomed in. So I'll zoom out. Okay. So I can see my, here's where I assert A is equal to AB. I could change the value if I wanted to look at that in hex. AB. And right here I can see when load went to 1, on the clock edge, the output went to AB. It was undefined before that, but as soon as the clock edge was high and the load was high, I got a value of AB as the output. And it cleared over here. Sorry. It stayed high even though the input was brought low. The output stayed high. The Q value stayed at the high value. It wasn't cleared until this point here. It was asynchronous because it did not happen on the clock edge. So I can get all the information that I need, or most of it, from this simulation. The other thing to note is that as I move this cursor around, it records the value of the variable here. So load and clock are high, and so on. So you can create your own table based on the information here. Okay.